Okay. So we are going to graph, it says sine and cosine, but we are going to throw tangent in here as well. We rearranged a few things with the snow day so that our test will fall on the NISA writing day. So your test will be the block period. Okay.
When is that?
Not next week, but the week after.
And then when is there another one that's next week?
Next week you do not have school on Monday. And then the following week, Tuesday, Wednesday is NISA writing. Okay, and then the rest of the NISA will not be until after spring break. Okay. All right, so we are going to look at unit circle values. Now, we've only talked about 16 coordinates on the unit circle, but there's an infinite number of coordinates in between each angle. We just talked about this special one. Okay? So we're going to talk about the graph of sine first. Okay? Sine comes from which coordinates on the unit circle? What? The y. Okay, so let's look at our y values. 0, 1/2, radical 2 over 2, radical 3 over 2, 1. Okay, so at 0 radians, we start at 0, and we increase in value until at pi over 2 radians, we are at 1. Okay, now look at the y coordinates. Radical 3 over 2, radical 2 over 2, 1/2, 0. Okay, so we decrease in the same pattern until we're back here at pi, we're back to 0. Okay, so we increase to 1, decrease to 0. Okay, then if we follow the y coordinates, negative 1/2, negative radical 2, negative radical 3 over 2, and we rotate all the way to 3 pi over 2, we're at negative 1. So from 0 we decrease to negative 1. And then if we follow our y coordinates back, we increase back to 0. Okay, that's kind of hard to visualize right now, so let me paint you a picture here. Here we go. Okay, here's my unit circle. This is going to rotate around and follow the y coordinates on our unit circle. Okay. Over here, it's going to paint us a picture. We started at 0, 0. Here at pi over 2, we're at 1. Here at pi, we're at 0. When we hit 3 pi over 2, we're at negative 1. And then when we rotate back to 2 pi, we're back to 0. So with one rotation around the unit circle, here is our graph of sine. Write it down. Y equals sine of x is this graph. Okay. What you need for sure are these 5 points on your coordinate plane. And notice how it's kind of an S shape, okay, if you want to think about it. Now, we can keep going around and around and around our unit circle. So this pattern is going to repeat over and over in both the positive and negative directions. Okay, so you notice how this just keeps oscillating. Okay, that's just going to happen over and over and over. We're not going to graph all of that. We're only going to worry about a chunk of our graph. Okay, but you need to understand that this is going to keep the same pattern over and over and over. Okay, so in both directions. Okay, what you need to be worried about are the points 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Those are the 5 points that are important to create the shape of your graph. this is what we call our parent graph. Okay, so we will be talking about some transformations with this parent graph. Okay, but I will teach you shortcuts when it comes to graphing these. Make sure when you draw your graph, it is nice and smooth. There are no corners. Just a nice smooth X. Okay. You ready to talk about the graph of cosine? Yeah? Okay. Let's talk about the graph of cosine. So let's go back to our unit circle. Okay? Cosine values come from the x-coordinate. Good. So we follow our x-coordinates around. Notice how we start at 1, and then when we rotate, radical 3 over 2, radical 2 over 2, 1/2 0. So those x values decrease until we get to 0. Right? Then from 0, we move to negative 1/2, negative radical 2, negative radical 3 over 2, negative 1/2. So as we rotate from 0 to pi, we start at 1, decrease to 0, decrease even more to negative 1. Right? And then if we follow our x values, we'll start increasing to 0 and then back to 1. Okay, if we follow those x coordinates. Let's look at that picture. So now we want cosine. Okay. So if we follow our unit circle, we start at 0 radians gives us 1. Pi over 2 radians, here we are at 0. Pi radians, we're at negative 1. 3 pi over 2 gets us 0. And then rotating all the way back to 1. Okay. Taking all the unit circle values, okay, even the non-special ones, we get this shape. Okay. Does it look similar to sine? Yes? Okay. It should, right? They come from the same values, just at different spots. Okay? So here is the graph of cosine. What I have highlighted in red is what's important. Those 5 coordinates are important, but you need to understand that this is going to oscillate in both directions. This pattern is going to repeat over and over and over in the positive and negative direction. So the points that you need to be concerned about are 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. Before we can start graphing these, we need some vocabulary. Okay? These graphs are much different than anything else we've graphed before. Do you agree? Okay. I want you to notice that first of all, the x-axis has been angle measures. Okay? We plug angle measures into our trig functions, and so the x-axis is always going to be angle measures. Okay? Our y-axis will be our output values, okay, the values we get after we plug in those angle measures. So those will all be rational numbers, okay? Well, real numbers, we'll put it that way, okay? So the first word we need to talk about is amplitude. The amplitude, it sounds a lot like altitude, doesn't it? Okay. Amplitude is half of the vertical distance between the highest and lowest points on the graph. The amplitude is half of the vertical distance between the highest and lowest points on the graph. You could also think of it as half of the height, if you will. Okay. The graphs y equal sine of x and y equal cosine of x, they have the same amplitude. Okay, the parent functions have the same amplitude. So I'm going to go back a couple slides. We're going to look at the graphs of each of these. Okay, here's the graph of sine. Our highest point is where? At height of 1. Our lowest point is -1. So those two have a distance of 2, which would make our amplitude 1. Our amplitude is going to be half of the total height. So since we stretch from -1 to 1, that has a height of 2, our amplitude is 1. Okay? You can think of it as what's the height from the middle? There's the middle of our graph to the top. That has a height of 1. Okay? If we look at the cosine parent function, okay, this also stretches from a height of 1 to a height of -1. Okay? So that total height is 2, which means our amplitude is half of that 1. Okay. Now you notice with both of these graphs, they repeat over and over and over and over again, right? They just keep oscillating in both directions, okay? They follow the same pattern. Okay? Each graph will have what we call a period, okay? The period is the horizontal distance between a point on the graph and then a point where the graph begins to repeat itself. So the horizontal distance between a point on the graph and then the next point where we begin to repeat our graph. So we're going to talk about the period for y equals sine of x and y equals cosine of x, because the period of our parent function will be important for understanding the periods of other functions that have been transformed. Okay, so I'm going to flip back here to the graph of sine of x. All right, if we pick this point right here, where does our graph begin to repeat? At 2 pi, we begin our same pattern. So, from 0 to 2 pi, all right, we say we have a period of 2 pi. Okay. Same thing here with cosine. If I start here at 0, we begin to repeat our pattern at where? At 2 pi. All right. So, the cosine also has a period of 2 pi. Okay, so So right now, you could graph y equals sine of x. You could graph y equals cosine of x. All right? Probably not going to ask you to graph those two. You need to understand those graphs, but we need to be able to graph these functions that have been transformed. Okay? So let's talk about how values can affect these graphs. Okay? So I'd like you to write this down. If we're talking about y equals a sine of the quantity bx minus c plus d, or y equals a cosine of bx minus c the quantity plus c. Okay. Since sine and cosine graphs are so similar, all right, A, B, C, and D are going to affect both of them the same. Okay. Remember, transformations are the same with any parent function, all right? We just have to figure out how they're going to affect this type of graph since we have things like amplitude and period, okay? So first of all, A, what does A do to any function? A number multiplied outside. It's going to stretch or shrink vertically. If it's outside, it's going to be vertical, okay? So A is going to affect our vertical stretch or shrink. What do you think specifically with a sine or cosine graph that's going to affect? The amplitude. Okay. A is the amplitude. Well, really the absolute value of A, because it is possible for A to be negative, but an amplitude we need to think of as a positive number. Okay. So absolute value of A is going to give us our amplitude. All right. What if A is negative? Okay, but what does that mean about our graph? Okay, if we have a negative A, then we know that our graph is going to reflect about the x-axis. We will talk about what that looks like for each of these. Okay. B, what does a value in front of the x do? Okay, a number multiplied outside stretched or shrunk vertically. A number multiplied inside stretches or shrinks horizontally. So specifically with the sine or cosine graph, what's that going to affect? The period. Okay. Now the period of a just plain sine of x and cosine of x, our parent functions, is 2 pi. So if we have a b value, our new period would just be 2 pi divided by b. That's going to give you your new period. Now, how do C and D affect our graph? Those are our shifts, right? C is a what kind of shift? Horizontal. D is vertical. Now remember, if there's a number multiplied to x, that does affect your horizontal shift. Okay? So, your horizontal translation, okay, is C over B. Please also notice that in our equations up there, we have bx minus c, okay? So our horizontal translation is c over b. Our vertical shift is d, okay? This coordinate c over b comma d, we're going to call our starting point. Okay, that is going to be our starting point. I'll tell you what that means in a little bit, okay? But we will have a starting point, okay? Any questions about what these mean? Before we graph, we are going to practice identifying these three things. Well, kind of four, but I'm going to call them three things. Amplitude, period, and starting point. Okay, you have to identify those before you can graph. So we're going to do that first. Okay? So our first example is y equals 4 sine of 2x minus pi over 3 minus 2. So let's just identify all of our values. A is, what's A? 4. B is, C is, pi over 3. Notice how it's a positive pi over 3. And D is -2. All right. So what is our amplitude? What is it? It is 4. Okay. Our period. How do we find it? 2 pi divided by b. So our period is pi. 2 pi divided by 2, which makes it pi. All right. Our starting point. We have to take c divided by b, comma, d. So the hardest part in all of this is the c divided by b, because you're going to have fractions and fractions. What is pi over 3 divided by 2?
Over 6.
Pi over 6. Because this is the same as pi over 3 times 1/2, right? Multiplied by the reciprocal. Let's practice another one. Here I have y equals -4 cosine of the quantity x plus 3 pi over 2. What's our amplitude? 4. Thank you for saying +4. That negative just means what? We have a reflection. Okay? So sometimes I like to make a note to myself, hey, it's going to be reflected. Okay? Our period, we find by taking 2 pi divided by b. What's b? Okay, so 2 pi divided by b gives us 2 pi. Our starting point, c over b. What is c? No. What is c?
-3
-3 pi over 2. Since b is 1, c divided by b is -3 pi over 2, and then d is 0. Remember, well, first of all, when we talked about these equations, that was bx minus b. Because anything inside our parentheses, inside with x, is kind of backwards from what we want it to be. All right? Okay. So, I'm going to give you a handout to help you. We are going to graph by what I call the framing method. Okay? We're going to draw a frame and then put those 5 special points in. You know those 5 points that I made you graph for each of them? And I said, hey, these are the most important. Okay? This is one. Okay? Everyone have one? We're starting with the sine and cosine side. Okay. This is how we make our frame. Our starting point does not tell us where our graph starts. Our starting point tells us where our frame starts. Okay? So our frame, okay, we're going to graph our starting point first. Our amplitude is half of the height. So from our starting point, we're going to draw up the amplitude and down the amplitude. Okay? Our period stands for the length of one cycle, if you will. So for our frame, the period will be how long we make our frame from our starting point. Okay? So you're going to graph your starting point, draw the amplitude up and down from it, draw your period, the length of your frame. Okay? Now we have 5 important points. Okay? So what we're going to do, we're going to, with dotted lines, split each box in half lengthwise. And then we're going to split it into fourths. Okay? So you'll cut the frame in half and then cut those 2 halves in half. Okay, so we're splitting it into fourths. So with your frames, go ahead and make dotted lines in half lengthwise and then cut them into fourths. So cut it in half and then cut the 2 halves in half. Go ahead and do those with your 2 frames. We are going to talk about how our graphs fit into these frames so that when I give you a function, you can identify those 3 things we talked about, draw our frame, and then you know how the curve's supposed to fit inside of your frame. Okay? Do we all have our boxes? Our frames, excuse me. Dotted lines? Your paper should look like mine, right? Okay, so let's start with a sine function that has a positive a. We already know what this looks like, right? It should look like that S, correct? So our 5 important points. The sine function will start on the starting point, and then it goes up to the top of the frame, back to the middle, then down to the bottom of the frame, and then back to the middle. Each one of these 5 points should be on an intersection of a dotted line, either with the frame or another dotted line. All right? And so then this is what makes our S shape. What would happen to this if A was negative? Here our S shape goes up first, correct? If A is negative, what would happen to our S? It would go down first, so we're still going to start on our starting point, but we would go down first. Okay. Now our cosine graph does not start on the starting point. What does our cosine graph look like? Okay, it starts up at 1 and then it's kind of like a big valley, if you will. Okay? So our cosine graph will always start in a corner. Alright? So we're going to start up here at the top corner. Then we're going to hit middle, down to the bottom of our frame, back up to middle, and then back to the top corner. When you connect these, make sure that you have nice, smooth curve. And we know from the top of our frame we'll start, we would have another valley. Okay. So here's that graph. If cosine was negative, we wouldn't have a valley, we would have more of a hill. Okay? So instead of starting at the top of our frame, we're going to start at the bottom of our frame and make a hill. What? Okay. So, you have some instructions on that sheet. So let's talk about them. You're going to identify the amplitude period and starting frame first, or starting point first. With that, you are going to plot your starting point. Okay. You're going to draw your frame. We talked about drawing it up and down the height and then over the length of the period. Okay. Then you're going to sketch your 5 points and label them. All right. And then we can talk about domain and range. Okay. First example. What is our amplitude? 1. There is a negative, which means what? Okay, we are going to have a reflected sine graph, okay? Our period. 2 pi divided by b. What is b? 1. So we just have a period of 2 pi. Our starting point, C over B. What is C? Negative pi over 2 divided by B. What's B? 1. So I'm not going to write divided by 1. Okay. So here's C over B, comma, D is 3. So here we go. Our starting point is negative pi over 2, 3. Okay. So here I'm going to call this negative pi over 2. And then I'm going to go up 1, 2, 3. Okay. Our amplitude is 1, correct? So what does that mean about our frame? From our starting point, we're going to go up 1 and down 1. So our frame should stretch from 2 to 4. Now we need to draw the length of our frame. How long does it need to be? It needs to be 2 pi in length. So if I'm over here at negative pi over 2, and it needs to be 2 pi in length, where is it going to stop? 3 pi over 2. There's our frame. Okay. We're going to cut it in half. When we cut it in half, this way, what's halfway in the middle? What's halfway between negative pi over 2 and 3 pi over 2? Okay, if that wasn't obvious, what could you do to get halfway between? How do you get the middle of something? Huh? Okay, we can add our two outer numbers and cut them in half, right? So pi over 2 is where we are in the middle. Halfway between negative pi over 2 and pi over 2 is 0. Halfway between pi over 2 and 3 pi over 2, pi. Okay, we have our frame drawn, so we can put in our sine curve. Does our sine curve start at the starting point? Yes, it does. Sine starts at the starting point. Now, we have a negative a value, which means, are we going to go up or down first? Down. I do want you to label each of your points. Okay? So here this is negative pi over 2, 3. This is 0, 2. This is pi over 2, 3. This is pi 4. And this would be 3 pi over 2, 3. Any questions? Move to a cosine. Our cosine curve, 2 cosine times pi x plus pi over 3, and then minus 2. Okay? What is our amplitude? Our period is 2 pi divided by b. What is b? B is pi, so 2 pi divided by pi is 2. Our starting point, what is c? Negative pi over 3, and then we have to divide that by b, comma, d is negative 2, so c over b reduces to what? Negative 1/3. So our starting point is negative 1/3 2. You'll look at my frame on here. our starting point is at negative 1/3, negative 2. Okay. Our amplitude is 2, so we're going to draw from our starting point our frame up 2 and down 2. Okay. How long should our frame be? What? 2. So if I started at negative 1/3, where will our frame stop?
I was thinking, I wasn't sure if I just took it 2 units over from 1/3.
Well, if we're at negative third, we want to go 2 units over. So negative 1/3 plus 2 is, okay, so, which is 5/3, right? Okay, so we're going to cut it in half. And then we're going to cut it in half again. What is halfway between negative 1/3 and positive 5/3? Add them together, divided by 2. 2/3 is halfway between. What is halfway between 2/3 and 5/3? Add them together, you get? What's 2/3 plus 5/3? 7/3. Cut in half would be 7/6. Halfway between negative 1/3 and 2/3. Add them together to get 1/3. Cut it in half. 1/6. Okay. I'm labeling those for right now. I'll erase them when we label our points. Okay. So here's our frame. The frame is the hard part. Now we just have to fill it in. We have a cosine curve with a positive a. Where do we start? Where do we start? In the top corner, not on the starting point. Okay? And then we hit down, middle, up. Okay? So then we're going to label our points. This point right here is negative 1/3, 0. This point right here, that was at 1/6, so 1/6, negative 2. This point right here is at 2/3, negative 4. This point right here is 7/6, negative 2. And this is 5/3, 0. Okay. All right. You guys are hanging tough. I know this is a long lesson. All right, but we need to go slow to get piece by piece by piece. Tangent is going to be easy now. All right. I want you to look at the unit circle. It's okay, guys. We have plenty of time. I want you to look at the unit circle. What's true about the tangent of 0? It is 0. What's true about the tangent of pi over 2? What's true about the tangent of negative pi over 2? Undefined. What happens when we have undefined values in a graph? We have what? A hole. It's not a hole. What's another option? An asymptote. Our tangent graph has asymptotes at pi over 2 and negative pi over 2. Okay. And it looks like this. What's the distance between each of my asymptotes? What? Pi. Okay, the distance between each of my asymptotes is pi. So tangent, we say, has a period of pi. I'm going to stop here. Alright? What I will have you do is I would like you to complete these problems right here. These two are tangent problems. We will talk about how to graph those tomorrow. Okay? So I want you to only worry about the top portion. I believe your book says to graph 2 periods. You can try if you want to, all right, but I'm only going to be worried about 1 period. Okay? So graph 1 period. If you want to graph 2 periods, you can just copy paste a second frame. Okay, you wouldn't have to label anything. I do want you to label the 5 critical points for your sine and cosine curves. Okay, so we guys, we still have a couple minutes. Okay, tomorrow I will talk about your quiz because I want to talk about it in detail. We will talk about how to graph tangents. Okay, we will obviously go over questions on your homework. I'll have graphs for you to compare yours to mine, so you can check in the back of the book, but it's going to look funny. Okay, so I will have graphs so you can check your 5 critical points. Okay, and then we'll also talk about how to go from a graph to an equation. All right, but you know what a tangent graph looks like. We'll talk about the specifics of graphing them tomorrow. Do not lose that blue sheet. On the back is how to graph a tangent. Don't lose it. Are there any questions? Your grades for your quizzes are online.